we are going to look at simultaneous equations. Again, that's why it says part 2, and that's because quite a while ago you already learned to solve simultaneous equations using a method called elimination. I will take a minute to remind you of what that was, and then I'll show you another method called substitution. So substitution is the skill that we're going to practice today, but I just want to take you back real quick to remind you, what are we really doing when we're solving simultaneous equations? And I know we can get lost in the fun of solving them and finding answers, but what are we really doing? The simultaneous equations that we're solving are always straight lines. They're always equations of a line, like you could plot them on axes. Say we have the equation y equals x. That's this line if you plot it. And we have an equation y equals negative 2x plus 3. If you were to plot that, it would look a little bit like that. What we're looking for when solving simultaneous equations is for that one point where these lines meet. This is the only point where the y and x values of these two lines are equal to each other. Like the orange lines x and y value are equal to the blue lines x and y values. So this is the point where the lines meet. When we solve simultaneous equations, we're looking for that one point where the lines meet. And that's why we always find an x and a y value. We're actually finding the coordinates. Okay. You've looked at a situation like this before. These are two equations. They could be plotted as two separate lines. Where do they meet? What we've done before, which we call elimination, was to line them up and then, as we call it, add the two entire equations together to get rid of y. We're eliminating y. And this is what that looked like. We want to add because a plus 2y and a plus a negative 2y add up to nothing. So 3x plus x is 4x. 4x equals 12. Then we would solve for x. Remember, divide both sides by 4. X equals 3. And then we have to remind ourselves that we're not done because we need to find the value of y. So we plug x into either one of these equations. Let's do this one because it looks easy. So plug in 3 for x. 3 minus 2y equals negative 6. I want to get the y's over there and the 6 over there. I'm going to add 6 to both sides first. 9 minus 2y equals nothing. I'm going to put 2y over there. 2y, and apparently y equals 4.5. So we could say x equals 3, y equals 4.5, or we could say 3, 4.5, state it as coordinates. This is what you already know, called elimination. Now I want you to realize that here in this bottom equation, x is by itself, so we could easily rewrite this equation with x as the subject and then see what we can do. Let's rewrite the whole thing. 3x plus 2y equals 18, and x minus 2y equals negative 6. So let's take this bottom one and make x the subject. X equals 2y minus 6, right? I added 2y to both sides. Now I've defined x in terms of y, and I can substitute this for x into the other equation. Not into the same equation, because then I get weird stuff. I'll get 0 equals 0. Okay, not very helpful. I can plug this in for x up here. Let's do that. So the original equation was this. Apparently x equals 2y minus 6 at the point where the two lines meet. So 3 times 2y minus 6 plus 2y equals 18. And then I solve. I expand. 6y minus 18 plus 2y equals 18. Collect like terms, 8y. I move 18 over there. 18 plus 18 is 36. Y equals, really, we're doing half numbers again. Okay, 4.5, right? Yes. Yes. Y equals 4.5. Now I substitute this back into, let's say there, right? So if x is 2y minus 6, x equals 2 times 4.5 minus 6. So x equals 9 minus 6, which equals 3. So the coordinate of the point where the two lines meet is 3, 4.5. This method, changing one equation to have x as its subject or y, one of the variables as its subject, then substituting that into the other equation, that is called substitution. Substitution. That's the new skill. Let's do one more. This one. Let's look at it. I like the fact that this top one, this is like ready to be substituted, right? Y by itself equals something in terms of x. So instead of writing y down here, we can substitute this part. Let's do that. 2 times, not y, but 10x plus 47 minus 5x equals 34. Expand. 20x plus 2 times 47 is 80, 94 minus 5x equals 34. 20x minus 5x is 15x. Let's subtract 94 from both sides to give negative 60. That means x equals negative 4. So I found my x. Now I substitute that back into either one of these two. Let's do it up here because I like multiplying by 10. So let's write y equals 10 times x, but I don't write x, but negative 4 plus 47. So what does y equal? Negative 40 plus 47, which equals 7. So the answer is negative 4 for x and 7 for y. Right. So it doesn't matter whether you get x or y by itself on one side. Whatever is easiest, you just check out your equations and see what's easiest to get. And here it's like it's given. Substitute this for y into your second equation so that everything is just in terms of x. Find the value of x, then plug that value of x back into one of the equations to find y. There you go. Have fun with it.